to you all. You are welcome to today's class, MTA 303. So let's quickly look at the surface integral. If time permits us, we'll move to the volume integral. So let me quickly share my screen now. So, can you see my screen, please?
Yes, sir.
Okay.
Yes, sir.
Is this question, let's look at this question before we solve the integral per se. I think you should be able, I'll just give you the highlights and I want you to go and solve it. Number one, if phi is equals to 2xyz squared and f is equals to xyi minus zj plus s2k, and c is the curve s is equals to t squared, y is equals to 2t, z is equals to t cubed. From t equals to 0 to t equals to 1, evaluate the line integral a of c along the c, the phi r, b along the c, f cross the r. So who can tell us what to do at this point? What comes to your mind when you have a question like this? Anybody? Are we there?
Yes, sir.
Yes, sir.
Samuel, what will you do?
Okay. Sir?
Ola,
Sir?
what will you do?
I'll give it a try, sir.
Go ahead.
Okay, so since we know our phi for question A, we're giving our curve to be along t is from 0 to 1. So we have integral of 0 to 1. Then the phi is 2xyz squared. Then the r, we know that our dr is the xi plus, am I correct? Plus the y plus the yi plus the zi.
Okay.
So what we're going to do is that we're going to say 2xy z square, the iy. We're going to multiply our phi by the xi, then the the yj, and then the zk.
Remember, you are given t, and everything must be in form of t. First thing I expect you to do is to substitute your s is equals to t squared, y equals to 2t, and z is equals to t cubed. Did you see it there?
Yes, sir. Yes, sir. Yes.
Please remember, that's why I give you this question. I know majority of you will just jump into the integration. Look at it, 2 of t squared. What is y? 2t, and z is what? T cubed or squared. You see? So we have to merge this thing together. When you merge it together, 2 times 2, 4. We have t squared here. T squared multiplied by this, what do you have? T9.
T raised to power of
Don't worry, I will help you guys. Have you seen it? It's T9. Do you agree with me?
Yes. Yes, sir.
Hello? Only one person is talking now.
Yes, sir.
Because
sir.
this is T6 plus T3. What do you have? T9. So we define the R. R is Xi plus Yj plus Zk. And I know the same R returns to, since I know my X, I know my Y, I know my Z, I'll substitute it. It will be T squared I plus 2Tj plus 3 cube K. Do you agree with me now? So I can
Yes,
now
sir.
say the R is equal to, that is, I'll differentiate the R dt. Let's say the R dt is equals to 2Ti plus 2J plus 3T squared K. So I can now, the R dt is the stop, but I need the R. So I can go ahead and get the R will be, just cross multiply the T. It will be 2Ti plus 2J plus 3T squared K. Everything multiplied by dt. So if you are now asked to solve the problem, it's very simple for you to solve. For us to solve it now, you can now say integral of phi, the R, is equals to integral of t of 0 to 1. So what is phi now? Our phi is what?
4t raised to power 9.
4t raised to power 9. 4t raised to power 9. In brackets, what is the R? The R is what? 2t
2ti
plus
2j
2j
plus
plus
3t.
3t squared dt. So I can open the brackets one after the other. I will now say from t equals to 0 to 1, I have 4 multiplied by 2. I have 8t10. Do you agree?
Yes, sir.
dt plus, let's say I is here, remember, j is here. Integral of 4 multiplied by 2 again. 8 t raised to power 9 dt plus k 12t raised to power what?
11.
Don't forget your limits, 0 to 1, 0 to 1. So I can go ahead and integrate them one after the other. When I integrate this first one, what do I have?
8t raised to power 11 over 11.
8 raised to power 8 what?
11. 8t raised to power. Oh,
8t raised to power 11 over
11 over 11.
Don't forget your limit, upper limit minus lower limit,
0 to 1.
plus your j,
8t raised to power 10 over 10.
8t raised to power 10 over 10, 0 to 1, plus k,
12t raised to power 12 over 12.
over 12, 0 to 1. So we only need upper limit in this case, because if you substitute 0, everything will cancel, right? So
Yes,
let's cut this one, go with this. Here 5, here 4. So we have, at the end of the day, when you substitute 1 into this one, will be 1. We have 8 over 11 I plus 4 over 5j plus k. That's all.
Okay.
Do you agree?
Yes, sir.
Yes, sir.
Then we do the same thing to cross. Remember, the second question says F cross the R. F cross the R. Let's quickly check F cross the R. B now. We have along C, we have F equals to XYI minus ZJ plus S square K. So we can substitute this one now. What is our dr? We know our dr to be what? 2ti
Plus 2j
plus
3t
2j
square k.
plus 2 what?
Plus 2j plus 3t square k.
Plus 3t square k. K dt. Then we have F cross the R. Don't forget the way you do it. F cross the R means not multiplication like that. It simply means now we know our F. Our F in this case is what? How do we substitute?
That will be 2. That will be x. X is t square. So we have t square multiplied by 2t. That's 2t cube.
2
T cube
t
I
cube I
minus t cube j plus t raised to power 4.
Good.
K.
Cross 2ti plus 2j plus 3t square k dt. So we can now go ahead and do the cross using the determinant theorem. I is what? 2t cube. We have j minus 3t cube k t4.
K.
K is here already. So we have 2t, 2j, and 3t. No, this is 2.
3t square.
Yes. So we can go ahead and do plus or minus our plus or minus. Plus, minus, plus. So if you do that, remember, we want to resolve. We've not solved, we are not integrating yet, though. We just want to solve what we want to integrate. That is what we are trying to do now.
Yes, sir.
So we can go ahead and say, when you take this side, everything here will paralyze. This one will paralyze, remain this. We have minus 3 t raised to power what? Do you agree? 3 raised to power 5, because
yes, sir.
minus 2t raised to power 4 I
minus j
minus, open the bracket, this will cancel, this will cancel. You have 6t t raised to power
5
minus
2t raised to power 5
j plus, this cancel this. You have 4
cube
minus plus 2 raised to power
t raised to power 5.
4.
4, yes, 4.
Okay. So we can go ahead and add the one we can add, leave the one you can leave, because you can only add few of them. So let's go ahead. So for us to integrate now, we have I is 0 to 1 of negative 33t5 minus 2t4 I dt minus, we can add this one together. What do you have? Integral of 40
raised by 5
dt plus, we can't add this one because they are not the same. Okay, integral of 40 plus 2t4 dt. Zero to 1. So when you integrate it very well, this is what you are going to get. Go and do it by yourself. Minus 9 over 10 I minus 2 over 3 j plus 7 over 5k. So, any question? So go and do that. So for the surface integral, surface integral, it has so many different aspects that we need to check also. One of the thing, the definition is okay, surface integrals. Under the surface integral, we have the definition to be integral x a dot n. Yeah, n is normal factor. We have a normal unit there. So, which is paramount to what we are, normal factor there is there, which is paramount to what we are doing. And we have to do the parameterization from the word parameterization. We have to do it, and I will solve questions. Then from that question, I will use it to explain the detail for us. I believe you can read your textbook or your notes. I don't know whether there is something there for you. How many of us have gone through the textbook?
Sir, I have gone through it.
We've gone through it, but it is not well explained, sir.
It's not well explained. What do you mean by that?
Then the textbook is not, it is not details enough.
Okay, it's not detailed. Okay. It's not detailed, it's different from it's not explained. You are a senior student now, you are supposed to read. That is why they put it like that. For senior student like you. Or are you not a senior student? People will be contacting you now. Please come and teach us this. They said you are in mathematics. Or you've not had before. How many of us have had that encounter before? And you now be asking yourself, which one is mathematics? Who told you I'm doing what you are doing? Is it not possible? Is it not the same thing you are encountering?
Yes, sir.
That is how it is. Even when we are in university, then they don't know that you still need to go and read what they want you to teach them. They believe that it's there for you just to pick it up and start explaining. Say,
You are right, sir.
It's not like that, though. So let's look at the example. When you have that's number one. If I have evaluate integral of xz plus y squared ds, where s is the surface, where s is the surface described by s squared plus y squared equals to 16. And then you have another limit to be 0 less or equals to z less or equals to 3. So what comes to your mind when you have something like this? Anybody?
So the only thing I'm seeing there is I'm seeing a circle. The equation given x squared plus y squared is equals to 16, which is an equation of a circle.
That's what you see. Okay, you see where? Okay, who else again? I want you guys to contribute to who else can see anything. Because if you cannot see from here now, you might not, I don't know what will happen before we finish the course. Yes.
Also, sir, I think we can parameterize a cycle from the given equation. So our x will be 4 cos theta and y will be 4 sin theta. So I think the z will represent the third side of the surface, sir.
Can you explain again?
I said, sir, we are going to parameterize the given circle, sir.
Okay,
So from the
if you are to
parameterization,
prioritize the given circle, which is, okay, let's say solution. For us to prioritize it, how do we do that? What are the formulas that are involved in this case? That's the first thing you need to know. Yes, prioritization is fine. In prioritization, you have R of theta, comma Z, right? Which is the same thing.
yes, sir.
Yeah, which is the same thing as, let's say you have S. Some people use U, comma V. How many of us have seen it before?
I have seen it, sir.
Okay. Some will tell you, though, we can use another thing. But in this case, what do we use?
We are going to use R and theta and Z.
Okay. From there, what next? R, theta, and Z. What next after that?
Yes, from there, we can obtain our DS, sir.
We can obtain what?
DS after
The
parameterizing.
X, yes. Our target is to get the X so that when you have the X, you can move ahead from the X and substitute it into your integral. Am I communicating? So
Yes, sir.
then how do we write the formula out? When you have R, let's say R is, let me use, let's say U comma V, Y is U comma V, and the Z is also U comma V. Okay, we have this one. Then the general formula for this one will be integral of X f of R, then the modulus of, or the absolute value of R RU cross RV, then dV dr. So how do we differentiate this? What is our dx? On a normal day, this simply means, okay, I'm supposed to give us the x first, but let me still go ahead. Where ds is equals to Ru cross Rv du dv. Sorry. Du dv. So it simply means the same formula I gave us up. All I need to substitute is just to substitute this is the area and this is the normal vector and the x. All I need to do is just to substitute my v, my ds into this equation, into this. So what does this thing mean? Now that we have different variables inside this place, it simply means our Ru will be equals to, let's differentiate it, partial derivative with respect to what? With respect to u. Because we already annotate it to be u, so it's going to be dx du, comma dy du, and dz du. So we do the same thing to the Rv, will be ds dv, comma dy dv, comma dz dv. So after we have all this, then we can go ahead and solve the problem. So how do we solve the problem? When we have all this, it is pretty simple. The same way we've been talking, that we have, when you have integral of x, f of x, comma y, comma z, dx, is the same thing that will now translation to the region R of f of x, comma y, comma z, absolute value of Ru cross Rv du dv. So, and we know our R of u comma v the vector RU, comma V is the same thing as where you have SU, comma V, YU, comma V, and Z, U, comma V. So we cannot go ahead and solve the problem. Let's look at the way Tayo put it the other time. You are saying something about sine and cosine. Can you explain further how do we reach there?
So from equation of circle and from
We have x squared
SOHCAHTOA
plus
S
y
squared.
squared equals to 16. And we all know
Yes, sir.
SOHCAHTOA right? What does the
Yes, sir.
S mean?
X will be 4 cos theta.
No, as in what's the meaning of X?
S means sine, sir. Sine.
Sine.
Sine. What's the meaning of C?
Cos.
Cosine.
Cosine, and T is what?
Tan.
Okay. Now that we have SOHCAHTOA, so I will know that so it's opposite over what? Hypotenuse, right? Are we there?
Yes, sir.
Okay. It's opposite over hypotenuse. Okay, now we have you said something here. What do you say we should do here?
I think it is better we'll draw the circle. So from this diagram, we can easily get our X and Y. And the
Okay.
radius of the circle will be 4.
So we have it this way. We have our Y, we have our X, and we know the radius is what? Remember the
4,
formula
sir.
for circle is x squared plus y squared equals to what?
R square.
Squared, right? And we know R in this case, we can divide it into 2 to be what? Which is 4 raised to power 2. Am I right?
Yes, sir.
So we have R to be 4. So when they ask you to do R theta, what do you have? So where do we see cos theta, sin theta? Where? How do we bring it out? I'm listening, Otayo.
So, our from the diagram, our hypotenuse will be 4.
Okay.
The opposite will be Y, and the adjacent will be X.
So are you saying this?
So from the origin, sir, we no.
Okay,
So
from the
origin, we connect the origin to any side of the circle.
Good. From here to any side of circle. So please, if you are the type that you don't understand what we are doing, please, you need to revise SOHCAHTOA and the circle and see how we use it to formulate our fragmentation. So we have R square R. So we can go ahead by saying R of, if I go back to the one I'm using now, so what are I going to write? Anybody? Yes. Who is talking? So 4 cos theta and 4 sin theta, then Z. Tayo, so I'm listening to you. Go ahead and explain.
So I say, I think since the radius is equidistant from all the circumference, so we need to connect the center to any point. From there, we'll get our x, and y.
Okay, from here now, where do
From
you
the
want us
center
to
of the
connect
circle
it to?
to any side of the circumference in the first quadrant.
First quadrant.
Yes, we form a right angle triangle.
Right angle triangle. So
yes,
now that we have it here, right?
yes. So from there, sir, yes, sir.
So you can pick, you cannot differentiate, you know, so means so S equals to opposite over hypotenuse. Which one is opposite here?
Our opposite is y, sir.
This side.
Yes.
And
no, that is our radius, sir.
This is our radius, which is 4.
Yes.
That we are
4.
dealing with.
Yes. The opposite is the y axis.
Y axis. And
yes,
this x axis is what?
The adjacent, sir.
Adjacent. Opposite and adjacent. So that is essence of this. And this one also can connect it depends any angle you want to go into. So let's move on. Now we form our R to have this. Remember, when you have this in R, what do you need to do? We still need to differentiate R with but before we differentiate, let's look at remember we are talking about one full, the limit we are using 0 less or equals to Z, less or equals to 3. That is it for Z. What about theta? What happened? Theta is 0 less or equals to theta, less or equals to 2 pi. Why are we using 2 pi? Because of revolution. One full revolution we are discussing now. Are we together now?
Yes, sir. Yes, sir.
Yeah. We are discussing about one full revolution. Kausara, are you still there?
Sir, yes, sir.
Somebody is gentle today. Okay. Don't worry, you will get it. So all we are saying is S is equals to 4 cos theta, Y is equals to 4 sin theta, and Z is equals to Z. So these are the things I put here. So it's not that big. So I've not done anything serious. So I will now begin to differentiate. Remember, I use this just as illustration to tell us what is expected of us. Is all this one. But now the major thing we need to do is just to now differentiate partially with our document here. You differentiate with respect to theta and you differentiate with respect to Z. So if you are differentiating with respect to theta using partial derivative, remember, we are dealing with X, Y, Z. So if you are using partial derivative, what do we do? How do we differentiate this one? Anybody? The S what? Okay, maybe I should write the formula down. Partial, the X, the what?
You mean the S the theta, sir?
The S the theta, yes. That's what I mean. Kausara, where is not clear to you? Are you there?
Yes, sir.
Which one is not clear to you? We've not solved the question. We are just laying foundation. Now we are just started solving the question. Look at it. Let me quickly explain this. From here, this is the question. Don't forget. Now, this particular one, I'm just using this one to illustrate, to explain the way the formula works.
Okay, sir.
Are you getting it now?
Yes,
I'm
sir.
just using this one to do that. The same formula, I'm now using it to write in terms of theta and Z that we know. Remember, the question was given to us in Z. So that's why I go back to it. So it's the same thing that I just explained here. This is just a kind of note that I'm just giving you. Are you getting it?
Yes, sir.
So this one, they are just explanation. Explanation in the sense that, number one, we need, if you want to write our own formula now, there is a way. Okay, if I ask you, how do you write your own formula using theta and Z? How do you write it? It is simple. The S equals to what? What is R? The R that I'm just defining is the same thing I put in this one. It's the same R that I put like this. All I just do is just do it in a column way instead of horizontal. The S, the U, the Y, the U, and I use it as the S, the theta, the Y, the theta, the Z, the theta. Are you getting it now? For
Yes, sir.
RV, I use it as the S, the Z, the Y, the Z, the Z, the Z.
Okay, sir.
Are you
Thank
getting it? So it's just the same thing. I'm not doing any other thing. So I'm just trying to define them first, then I will solve it. Mr. Samuel, are you there?
Yes, sir.
So the Z will be, so the S, what's the next now? The S what?
The Z.
The Z, the Y,
The Y, the Z.
and the Z. So these are the things we are going to now do. Let's now solve the R dz first. R theta, sorry. So when you differentiate 4 cos theta, what do you have?
Minus 4 sin theta.
Minus 4 sin theta. Then when you differentiate 4 sin theta, what do you have?
4 cos theta.
4 cos theta.
Then when you differentiate the z, the theta, what do you have?
Okay. 0.
Remember the z, there is no theta there, so automatically it's constant. So it's going to be 0. I hope you are here now. Let's do the z too. We have the z, the s, the z. Do we have the z here? Do we have z here? No.
No, sir.
So the first one will be 0. The second one will be 0. When you said the z is what? 1. Any question? Then from the formula we have, we need to calculate r theta cross r z. So r theta cross r z. We need that. R theta cross r z. So I, we have negative 4 sine theta. J, we have 4 cos theta. K, we have 0. We have 0, 0, 1. If you do this one very well, what do you going to get? You are going to have what? You are going to have anybody? Everybody do the determinant. Let me see. What do you have? The way we do I cross J, the same way, you know, if you pick this one now, what happened? This one cross, this one go, this will be what? 4 cos 4 cos theta multiplied by 1 minus 0. Excuse me. Minus this one cross, this multiplied by this, you have it to be plus 4 sine theta. This go with this.
4 cos theta plus 4 sin theta.
No, this one will do like this. So when you multiply by 0, this is multiplied by 0 plus 0. So the final will be what?
And that's 4 cos theta plus 4 sin theta.
I think our I and J they are missing.
You have I, you have J, you have K. So at
And
the
we have
end
4
of the
cos
day,
theta plus 4 sin theta. I and J.
but don't forget, you will not even have I and J again. Do you agree with me?
Yes.
Why, sir?
Okay. Now let's look at it. When you are finding, remember we are going to find this. We are going to
Okay,
find
the magnitude
absolute
of the
aptitude,
sir.
yeah, magnitude of it.
Okay, sir.
So let's just put it so that for the sake of other people, 4 cos theta I plus 4 sin theta J plus 0K, right? So
Yes, sir.
now that we now need to find the modulus, the magnitude, what do we have? Square root of what? What is the formula for this?
X squared plus Y squared plus Z squared, sir.
So what this one is telling us is, at the end of the day, what we have here is, for our X, we have 4 sin theta, no, 4 cos theta, sin theta, and 0. Do you agree with me?
Yes, sir.
So this is X, Y, Z. So we can substitute it here now by saying square root of 4 squared in brackets cos square theta. Okay, let me write it one by one. Don't let me disturb you. 4 cos square theta
It will not go that way, sir. It will be 4 squared cos square theta, sir.
4 square cos square
Cos square
theta,
theta.
right? Plus 4 square sin square theta. Are you getting it?
Yes, sir.
Something is common to them.
4 square is
4
common,
square is
sir.
common. Then we can write this one cos square theta plus sin square theta. which is the same thing as, I can take this one out. All this one equals to what? 1.
1. Yes, sir.
So which means I have square root of 4 squared, which is equals to 4. Now, everything we've solved is this one. No? So remember, you are going back to this place, because when you see something like this question and they give you 6 marks, they know what they are saying. No? You will work for that 6 marks.
So this type should be 20 marks, sir.
Okay, don't worry. That's mark. You will work for it. So let's go back to F now. We want to now integrate. This is where we are here now. We want to integrate now. What do we want to integrate? Who can tell us? What do we want to integrate? So our integral, remember we already we have our 0 to 2 pi and 0 to 3. Then go back to your equation, to the question you are given. What's the question says? Xy plus y squared. Please don't forget xy plus y squared. So xy, what is xy?
Sir,
Yes?
It is x. It is not x squared plus
XZ.
the f is given.
XZ.
No, this one.
We have to evaluate. Our f is xz plus y squared.
Where is it?
Is XZ, sir.
The
No, no,
question
no, no.
says evaluate it.
You don't get where I'm going. You need, at this point now, before you substitute, before you solve this problem now, you need to go back to that equation. Are you getting it? From this equation,
Yes,
you will
sir.
not get the detail. You will not substitute the x, everything there. We don't need, this is not, we are not talking about this one now. Don't forget. So this is what we are talking about. I'm not talking, the formula is there for us. So I'm just substituting into the formula directly. Remember, this one's supposed to be xy plus y squared, right?
Yes, sir.
Are you getting the analysis now? So for us to
Yes,
solve
sir.
the problem now, we already have our x and y. They are here. We have x, we have y, we have z. So we can go ahead and substitute into it. So what is x now? Our x is what? 4 cos theta. Am I right? Then
Yes, sir.
don't forget there is a z, because it's xz plus y squared. You have. So we have z. Let's just put z here. Or let me just say z. So I can come back to it. Plus what is y? 4 sine theta all squared. Put it there. Then multiply by the absolute value of
There's
this.
4.
Absolute value is what?
4.
And the z, the theta. Remember, if I want to write this formula down now, let's write it in a neater way. This is what we are doing. r theta cross r z dz d theta. So this is what this is what we are substituting to this place. So we can go ahead and solve this one. I believe you should be able to solve this.
And that is double integral, sir.
Yes. Double integral means you integrate the first one and you hold one constant. That's all. There's nothing big there. Okay, let's integrate it with respect to x, z. If you integrate this one with respect to z, what do you have? Remember, the first integral means with this. The second integral is for this. It depends the way you arrange it. So if I want to integrate that, okay, keep this one 0 to 2 pi. Let's integrate the first one with respect to z. So what do you have here? If I'm integrating this with respect to z.
4/2 cos theta z square.
Okay. You have 4/2 cos theta. Or let's say, why can't we say 4z squared? Right?
Oh, yes, sir.
Cos theta. It's more okay like that. Plus, how do you break this one down?
Yeah.
You might not even break it down.
Yes, sir.
Do you agree with me?
Yes, sir.
Just say all you need to do is just 4 sine theta all squared z. Then you substitute your limit, dz, d theta rather. So meaning that upper limit minus lower limit. So for this one, you keep this one 0, 2 pi. I want to substitute this one. This is 2, right? Z squared cos theta plus 4 sine theta square z. So let's substitute. If I want to substitute, what do I have? 2 into 3, right?
Yes, sir.
Cos theta plus
it is z square. 2
Sorry, 3 square.
into 2, 9.
3 square 9.
Thank you. At least you are here now. Okay, we still need to break this one. If you want to break this one, how do you break it?
16 sine square.
16 sine square theta
times 3.
Because if you put 0 here, everything will be 0. So you don't need it. Assuming it's theta we are dealing with now, we can say cos 0 is 1. But in this case, it's everything 0 multiplied by cos theta. That's what you have. So 9, this is 18 cos theta plus 3 times 6, 16.
48.
So if something is common to them, what is common?
18.
If I factorize 18, what do I have there?
Cos theta plus 3 sine square theta. No.
It's 6.
Kilo,
18
what
will
is
not
common?
go.
6.
6, right?
Yes, yes.
Because if you said 18, can 18 go in 48?
No, sir.
So you have 6 out. Then what do you have here?
3 cos theta.
3 cos theta. Plus what?
8 sin square theta.
8 sin square.
8 sin square theta. So
The theta.
the theta. Now you can integrate this one and substitute the pi there. If you do it very well, you have this 192 pi. If you substitute it very well, you have this. So what I will advise you guys is we all need to go a long way to be able to catch up with this. So the second phase, because of our time, I also have another meeting now. I'll see. Come here. Let me stop sharing.